Okay, so this next one here, the milk is spilt on a table and it's spreading and the circle is growing in radius. Okay, so the area is increasing at a rate of 10 centimeters square per second. So that's how much milk, how the area is growing. At what rate is the radius increasing? At five, I think that should be centimeters. I think that's a typo. Okay, increasing when the radius is 5 centimeters. So again, we need to relate the area to the radius. Well, for a circle, we know that the area of a circle is equal to pi r squared. I want to differentiate this with respect to time. So I have my dA by dt, which was given, times 2 pi r, and r is also given. But we also need to, since r changes with time, r is a function of time, we need to apply the chain rule. Okay, so that's what we're looking for. We're actually solving for that. So once we actually come up with the equation, differentiate with respect to time, we're just plugging in 10 centimeters per square per second. We know that this is 5 centimeters. Okay, and then we want to find out dr by dt. So this is going to be 10 pi centimeters. We're going to divide that by 10 pi. So we're going to get 1 over pi. Centimeters squared divided by centimeters is, we get 1 centimeter per second. Sorry, 1 centimeter over pi seconds. 1 over pi centimeters per second change is my dr by dt. Okay, so there it is. And again, notice that the units work out nicely. So next one, the man climbs on a cliff. He's 200 meters from the observer. Okay, so he's on some cliff. I don't know where the man is. Okay, so he's climbing at a rate of 10 meters per minute. So it's increasing his height by 10 meters per minute. So what rate is the angle of elevation changing for the observer to follow his progress? Okay, so we have this. Okay, let's simplify this. This is the AB. Where's AB? AB, so he's right here. So he's going to be climbing up along this line here. Okay, so the diagram's got lots of lines everywhere, but really he's just climbing up along that line. And he's at, right there, let's say that's 200. Okay, so let's say that's 200 meters right there. Okay, and there's some angle theta. And that angle is increasing as the man gets higher and higher. Okay, so we need to figure out how is the angle changing as he goes up. So we need to relate the height to that angle. Well, we know that the opposite to the angle, where this is constant, okay, this distance is constant. Sorry, they said AB is 200. Okay, so, and that was also 200. 200 meters from his climbing rate. What's the rate of angle observer following his path? Oh, sorry, we don't know that. So that's a height. Okay, so we know that we want to relate the height to the angle. So we know that height over 200 is equal to the tan of that angle. So that's our relationship. Okay, so I'm just gonna, I can just leave it like that. I can solve for h if I wanted to. So I want to figure out d theta by dt. I've been given dh by dt. Okay, so I'm going to differentiate. So 1 over 200 dh by dt is equal to secant squared theta times d theta by dt. Okay, so I want to find that. I got to figure out my angle. And it doesn't really tell me the angle, so I'm just going to leave it like that. So we are not actually given a height, I don't think. Yeah, so in this problem, we haven't been given any height. So we're just going to have to generalize this. So dh by dt is 10 meters per minute. Okay, this is going to be 1 over 200. And I'm going to divide by secant squared, which means I'm going to times by cosine squared. So cosine squared theta, that's going to be my d theta by dt. Okay, so I'm just going to simplify this a little bit. It's going to be, and I need to cancel out those units. I need to get rid of those units actually, because the units will end up canceling out, but it's going to end up being fairly complicated to show those units. So I'm just going to show it with cosine squared over 20 is going to be my d theta by dt. Okay, so that is going to be the change in my angle to the change in time. And if I know the angle, okay, where he is on that cliff, I can give you a numerical value of how fast that's changing.